Interaction. So, we're talking about sets today. There's a couple different ways that they have set notation. One of them is kind of the basic. Let's say this is the set of Bob's pets. So they use braces like this. And let's say he has dog, cat, and hamster. Okay, but the other way that they might possibly write it is the set of Bob's pets is X, where the set B is X, where X is Bob's pets. So this one kind of specifically says what it is, just lists it out, and this just says generally. What's in set B is X, and then this describes what X is, all Bob's pets.
X meaning like the number of pets? Or like
No. X would be like dog, cat, hamster. So that's just two different ways writing the same thing. Mostly it'll be this. If it was like a number, they use this more for numbers like X, where X is like between 2 and 7 or something like that. So it could be like 2.1 or 5 or whatever. So that's more for numbers, but you know. Could be. Alright, I'm on the wrong page. Problem number 1. Okay, well, let's say that's Bob's pets and Susie's pets are, we'll say she has a dog
a chinchilla
and a cat
and a turtle.
and okay, a turtle, fine. So those are Susie's pets. Well, in set notation you can use equals. Do you think Susie's pets equals Bob's pets? No. They gotta be exactly the same, just like you'd guess. Okay, so that's not really a new concept, but what is new, something that's new, is this symbol means a subset. Guess what subset means?
It's like a set of numbers that has so.
So, is Bob's pets a subset of mammals?
Yes.
Yeah, because hamster, those are all mammals, so yeah.
So subset.
So everything in this set has to be in this set. Okay, if this line is not underneath it, it's called a proper subset, which means they're not equal.
How did proper?
So would like
Okay, so normally if I just say subset, it could be everything in here is in here. Okay, but also they could be the exact same thing. Like everything in here is in here, but also there's no like extra things over here. So this is a subset, and it's also a proper subset because there's more in this one than just these. So you remember how like on less than, it's like less than or equal to? That's kind of what this means, but this is actually a subset.
so
But it also means it could be.
so if it was mammals it's a subset of Bob's, that's wrong.
Right. Mammals are not a subset of dog, cat, hamster. But dog, cat, hamster are a subset of mammals.
And can you
Okay, here, let me give you an easier example. Let's just say, is 1, 2 a subset of, these take too long. 1, 2, 3.
Yes.
Yes. Okay. Is it a proper subset?
Yes.
Yes. Okay.
Wait, why is it?
Okay, because it's less. This is basically means equals to. It's called when you take it out, it's called a proper subset. Is this a proper subset?
No.
No. So it has to have the equal to line on that.
Why is it not?
because they're the exact same thing. So the definition of subset is everything in here. If it's a subset of everything in here, that means everything in here is also over here. But normally it means there's more over here than just this. That's a normal subset. Proper subset, if it has this line, it's a subset and they can't be equal. Okay. I don't know how many times I can say it, but kind of skip something. So, each thing inside the set is called an element. So this set has 3 elements: dog, cat, hamster. You could say that dog is an element of
Giraffe.
Bob's Pets. Okay, dog is an element in Bob's Pets. Dog is an element in Susie's Pets. Okay, so this means it's one of the things in the set. So this is one thing that's in this set. So this is only used for an element.
Is it only used for one object, or can it be like dog and cat?
Just
are
one.
elements?
Just one. Okay. If a set is empty, like the example they gave was like set C is X. Those things. X where X is. They did like 1 less than X less than 2. X is integer. Okay, do you guys remember what integers are? Like, no. Well, it's all the whole numbers and all their opposites, so like negatives, and anyway, there's no fractions or decimals. So what integer would be between 1 and 2? Nothing? Nothing. So if it's a nothing, it's called a null set or empty set. So you guys have seen this last year though, right? It could be that, or you could just draw empty. But nothing in there. So you can also put slashes through these things, like this is dog is not an element of, or is not a subset, or is not equal to. So if the slash goes through it, just means not. All this stuff, by the way, is kind of scattered around, but it's on like page 2 and 3 and in there. All right. Here's another important idea. We kind of had this last year. You guys remember the and the or stuff from last year?
Yeah.
Okay. This is called intersection. That was kind of like the and from last year. And this is called union. That was like the or from last year. Okay, let's start with union actually. So let's go back to the pets that I was talking about earlier. We had Bob and Susie. So if I drew a Venn diagram, you guys remember what that is?
Yep.
This picture, that representative picture that has like
In
circles.
the middle is the same.
Bob and Susie, so what the overlapping would be what they both have. So what do they both
Dog,
have?
cat.
Dog and cat. But Bob had a hamster, and that wouldn't fit in Susie's. And Susie had a turtle. That wouldn't fit in Bob's. So dog and cat fits in both. So if you're doing a union, it's like open arms. Everybody comes in. So this set would be dog, cat, hamster, turtle. Okay, notice I didn't write dog and cat twice. Dogs are included, cats included, hamster included, turtle included. So everybody's invited. Got it? That's a union. But what if I did an intersection? What do you think that's going to be?
It's going to be not the same.
Okay, it's only what they have in common. So what do they have in common? Dog and cat. So it's only the middle stuff. Whoops, dag. Dog and cat. You have a dog and cat? Oh yeah, compliment. All right. Gosh. Okay. So let's say this is kind of a new idea. Also, the universal set means everything that can be chosen in this whatever we're talking about. So maybe I'll say the universal set is the integers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm limiting to just that, integers. So no fractions or decimals. If the universal set is 1 and 10, and let's say that set A is like 1, 2, 3. Okay. Then this little symbol right here is called the complement of A. It basically means what's not in A. So what's not in A, if we're limiting all possibilities 1 to 10, would be 4, 5, 6, 7, 8, 9, 10. So that's how complement works. So everything that's not in A that can exist. If I didn't limit it to this, it would be like almost infinite, right? Well, it would be infinite.
Is it always limited to 10?
No, I just made that up. So if your universal set is not limited, then
Say greater than.
it would be an infinite set, so it's kind of hard to write. Well, you couldn't even say just greater than 3 because it could be less than 1, it could be decimals in between them. So it could be a mess. All right, let's do some odds. You guys ready? The party. Oh, it's not. I don't think this will be too bad. Famous last words. Okay, number 1 says describe each set using a list of its elements. So number 1 says set L is equal to X, where X is a letter in the word grace. So what are the elements of this set? G, R, A, C, E. They did put it in set notation like this, but I don't really care about that, I guess. Brace? No, I'm not gonna grade on that. Okay, on number 3, it's kind of the opposite. Describe the set using builder notation. So that's what they call number 1. Like X, vertical line, X is blah, blah, blah. So, it's kind of tricky.
Is number 2 the same thing?
2 is similar to number 1. Like, you just list what the colors in the flag are. Okay, so on number 3, builder notation, you're going to start with X, and then you're going to put the vertical line, and you're going to say X is what? So what are some ways, without listing it out, we could describe the numbers 2, 4, 6, and 8? Even between, let's say X is even, and we'll say even numbers between 0 and 10.
So these answers aren't like exact. So we're all going to be writing different.
Sometimes there's only one way you could probably say it, but sometimes, yeah, you could say it more than one way.
What is this?
Number 5. Oh, darn, I forgot that definition. Okay, equivalent, I forgot this definition, but all it means is that each set has the same number of elements. If two sets have the same number of elements, they are equivalent. So on number 5, you're supposed to say, are they equal, equivalent, both, or neither? Those are the 4 options. So on number 5, are they equal? No. Are they equivalent? Yeah.
And equivalents if they have the same amount of.
Same amount of elements. Okay. On number 7, are they equal? Nar. Okay, are they equal?
No.
Yes. The order doesn't matter. Like if you had a history, science, and math book, and a math, history, science book, do you have the same thing? Yes. Doesn't really matter the order. So they're equal. Are they equivalent? Yeah. If they're equal, guess what? They're automatically equivalent. But so we're gonna have to put both.
So technically,
So-
none of the answers.
Equal is cannot be one of the answers because if they are equal, they have to be equivalent. Number 9, Santa Fe, Boise, New Mexico, Idaho, Virginia. Are they equal, equivalent?
Equal.
Neither. So neither.
What? Capitalize that one, but you didn't add capitalize 5.
Yep, there's a reason. It's very deep meaning. Okay, number 11. Translate each sentence into symbolic notation. So we're going to write it in symbols. B is an element of set K. How do I write that with the symbol? You guys remember the element symbol?
Like wonky, like C.
Wonky. Yeah, I think of it
It's
as
like a
B.
C with an E line in the middle.
B is an element of,
Ooh.
that's probably a better element symbol than I drew earlier, of K. You guys need to, where does it show it in the book? Number 14 shows it. If you look at number 14.
Oh. What did you draw? Yeah. Yeah, I did too.
It's a weird thing.
It's a quirky thing.
Yeah, sideways pitchfork.
Sure.
No, it's just a fork, but sideways.
No, it's one of those type of pitchforks, you know, where they're like wires.
No, I don't.
Okay, anyways, 13. The set containing K, L, and M is not a subset of T. So set K, L, M is
So you
not
just put the slash through the E.
here. Well, this is not element. This is
Subset.
subset. What was the subset symbol?
C over.
Yeah, that thing. And it is not a subset, so scratch of T. So what's the difference between this symbol and this symbol?
One is and one is a sub, and it's crossed out.
Okay, this is just for one thing, like one thing in the set, one element. And this is for an entire set. Goes in there.
So how do you know whether it's a sub or an E?
If you're talking about one element, you use this. This element goes in this set. If you're talking about entire sets that fit in there, use that. Subset. Okay, number 15. Translate each symbol into a sentence. So it's the opposite of 11 and 13. So how could I write 15 as a sentence?
The set containing A, B, and C is not subset to the set of
Yeah, it's not a proper subset of D. Yeah, good job.
Yeah.
The set,
We have to, this is not.
it's a for a full sentence containing A, B, and C. I should remember that. Is not a proper subset of set D. Yeah, it's like my cursive F. Fancy. Sarah approves. How did they get from this to that? That's the question.
So like, to make it all
So,
squiggly.
they were going like here, and just dragged, and then they went like that, and then instead of picking the pencil up to go like that, they just went like that,
Yeah.
or something.
Yeah, what did you say?
Okay, Christmas pretty much.
Yeah, I think that's
Okay, anyways, getting off track. 17.
That is an element of set U.
What did the
Empty set.
empty set, or that you could say the null
What?
set?
No, that's not.
Is
The empty.
a subset of. Okay, that set U there, U actually is special. It means the universal set.
Oh my gosh.
Lots of new terminology. U is a special set if they use a capital U. It's a special letter. Universal set just means anything that can be used.
Okay, but how are we supposed to tell anything that can't be used?
Yeah. So it just depends on what they're talking about. They might say the universal set is male. It's just whoever defines it. Mammals or Ebens or Americans or whatever. Number 19. True or false? The empty set is a proper subset of every set.
False.
Well,
I knew you were gonna try.
it would be true except for, it's a trick question. It's not a proper subset of itself. Proper subset means it has to be less than, like there's not as much. It's not a proper subset of itself. So it actually is false.
I was right.
So like on 18, you guys see 18A? Just think of that subset symbol as like less than or equal to. So on 18A, is the null set less than or equal to 1, 2, 3?
More than.
No, it is not as much as 1, 2, 3, right? So that A is true. You guys get it? But on B, it means is the null set, the empty set, less than ABC? Yeah. So it's just like saying less than or equal to. They're both true because the null set's less than everything except for itself.
So wait, on A.
Bro, what is C? There's literally nothing there.
So
Okay, is the empty set a subset like less than or equal to itself?
Yes.
Yeah, because it's equal to.
Yeah.
Okay. D is the empty set an element of 1, 2, 3.
Bro, these are like,
No.
oh, I feel like people like Paxton would come up with these things.
Okay. This is
We were just talking
this is not
the depths of the universe.
geometry really. But there are a few days in the year where we'll need to know this stuff. And also if you guys take like logic or computer programming in the future, this is the kind of stuff you have to do. So anyways, but it's going to be useful just like a few times. So we kind of have to learn it. I kind of lost my place. 21, is that where we're at?
Yeah.
Draw a Venn diagram. What did that mean again?
The circles are grand.
Circles. Okay, so on 21, do those two sets have anything in common?
Yes.
Okay, let me read all the directions first. Draw a Venn diagram illustrating the relationship of each pair of sets. State a probable universal set in each case. Like what's the universe these are living in? So, yeah, they have something in common. So what's our picture need to look like? Two touching, overlapping, what?
Overlapping.
Yeah, since they have a state in common,
Kansas.
they need to overlap. Okay, this box, when if you draw a box outside, it represents the universe. I guess it didn't say we had to draw that though, so it's okay if you don't.
Bro, this is so true.
This is just Venn diagram stuff. Okay, so guess what I'm gonna have to put here?
You're gonna put Kansas on the inside,
Right.
Alabama, Arkansas, and Arizona.
Kansas is the only overlapping. So I'm gonna put Kentucky over here. And Alabama, Arizona, Arkansas. over here.
So if they don't have anything in common, you don't have to like. Put
Okay, if they don't have anything in common, what would it look like?
Just two circles.
Just like that. Okay, but it also has to say what's a probable universal set? Like what are we talking about here?
States.
U.S. states. So if I was using the box thing, I would just like write it out here.
Did we do like that?
United States. That sounds weird.
States. Do we have to put like U equals because it's a universal set?
Oh, you could. I don't think they even did that, but that's fine. Yeah, they did write U.S. states. That's how they wrote it. United States. Okay, 23. Do they have anything in common?
Yes.
Okay, this picture's gonna look a little different though because P is a subset of M. Do you guys see that? So what should the picture look like?
It's gonna be on the
No idea.
You guys know?
One on top of another.
One's totally inside the other.
What?
Because-
Death Star.
Because everything in P is in M. So this little thing, P is 3 and 5. It's going to be entirely inside of M. And M is 2, 3, 2, 4, 6. Oh, I don't need commas. I don't know why I did that. 2, 4, 6. This could have multiple answers, but what's the universal set maybe?
Numbers.
Could be 1 through 10.
Numbers.
Could be 2 to 6.
Numbers.
Let's see what the book put. They just put counting numbers. Like natural numbers. Like 1, 2, 3, 4, that kind of thing. Okay, I'll just put natural numbers, that's fine. So there's more than one possible answer for that, right?
Do you have to put a box around it, like we did the other one?
I said you didn't have to. If you want to visualize the universal set, that's how you would do it.
Yeah.
Okay. The book only, I'm just looking at the answer now. The book only wrote the abbreviations on 21. Smarter than me. All right. 25, you guys see the directions? Set A equals 1359. Set B equals 2379. Okay, set U, so the universal set is X, where X is a natural number. So what are natural numbers? Starting at 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to infinity. Okay, I'm gonna say on this part, I don't really care about the Venn diagram, but we need A union B. So what's A union B? What's that mean?
It's like universal
1, 2,
stuff.
3.
No.
Everything.
1,
Okay.
2, 5,
Oh,
9
yeah.
Like,
is the
I don't know what it's called, but it's the one, it's like.
Union.
add the-
It's union.
Union.
Not ours.
And it means what though?
All
Universal.
Every, no. Okay,
You're like 4.
when it's between two sets, it means union. When it's like U equals blah, 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 that's describing the universal set. So this means something different than this.
You can read many things. You're lying. It's a letter.
Okay, when it's between two sets, it means the union. When it's describing a set, it means the universal set. Okay, got it? And the way the book draws it looks a little different, I think. Like
So
they're,
union's the answer?
Bro, Mr. is literally being Neil deGrasse Tyson right now. Explaining the words.
there's just a lot of little definitions to get through. Like, what does union mean though? What do we do with it?
Everything is
We combine both. So if we look at sets A and B, what's the union of those two sets? What's the lowest one? 1, 2, 3, 5, 7, 9. 1, 2, 3, 5, 7, 9. So I'm just gonna put equals 1, 2, 3, 5, 7, 9. Just make sure everybody's invited. '24 though has the other symbol. What was the other symbol?
Intersection.
Intersection, and what did that mean?
Just the ones that they have the same.
Only the ones they share. Okay, we're almost done. 27. Okay, 27 says A intersection B, so only what they share, but then it puts that in parentheses and puts the little symbol. Complement. Okay, so let's, gosh, the way they wrote this answer. Let's start with, what do they have in common?
One and 3 and 9.
Just 3 and 9?
Yeah.
Okay. So basically we need all the numbers that are not 3 and 9.
Wait, so those,
So the complement flips it.
So there's a few ways we could write it. We need everything natural numbers except 3 and 9. Let's write, I don't know if I want to do it the way
wait,
it
so what
looks.
is 26?
Everything that's not in B.
Wait.
But it has to be a natural number still, that's the
What is
universal.
natural numbers?
1, 2, 3, 4, 5, 6, 7, 8.
So
One.
anything
So
that's
it's
not
1,
negative.
2,
Um,
6, 7, 8.
okay, let me show you how the book wrote it, and then I'll talk about another way to write it. So the book put 1, 2, 4, 5, 6, 7, 8, 10, dot, dot, dot.
Mm-hmm. Yes.
I thought
I
we couldn't put
understand.
3 in about
That
just
literally
one.
makes 0 sense.
I just
That
list,
makes so much sense.
I just listed all the numbers except for 3 and 9.
I thought you said it was natural numbers only.
Okay, another way we could have written it, X is a natural number, fancy N,
Was that that double N in?
and, or I could put but, X is not equal to 3 or 9.
I like yours better.
So, you could write it with words, but X is a natural number. It's an element that's in the natural numbers.
Bro, that'd be
But
like
it's not
science
equal to
programs.
Well,
Okay, both of them are okay.
I don't.
26 will look a lot like that one. 29. So 29. We're doing A. Let's start with the parentheses. What's A union B?
Everything.
Everything we had on 25, right? So let me rewrite 25 down. What do we put on 25? 1, 2, 3, 5, 7, 9. And we're supposed to intersect that with not B, which we're supposed to have done that one on number 26. So let me write it this way. I'll do my own notation. Okay, B is 2, 3, 7, 9. And I'll just go ahead and do not B. What's not in B? 1, 4. This is like what you're supposed to get for 26. 5, 6, 8, 10, 11. Dot, dot, dot. Okay, so what would the intersection of those two be?
One.
Okay, they have 1 in common. They have 5 in common. Anything else? No. So 1 and 5.
So our answer is 1 and 5.
1 comma 5.
Wow.
What is this used for? We use this to find what? No.
We're gonna be actually using it, I think, this week, but it's gonna be like what part of this line is included when you do the union of this ray and this segment or something like that.
Whenever we start of the board.
Like number 1?
Just
Like
zoom
before,
out all the way.
explanation. An explanation.
Oh.
Or if you could just like give us the answer later.
Yeah.
Dog cat turtle. That's what I got from that last one, was dog cat turtle.
Bro, what is number 16? Dude, look at number 16. What is that?
Into a written sentence?
Okay.
I hate that.
Well, all right. What did I say that little apostrophe was called?
The opposite thingy.
Well, yeah, but what was the word I used? Complement.
Compliment.
The complement of what?
A and B.
The what of A and B?
The union.
The complement of the union of A and B
Is
is
not.
not a
subset.
subset
A subset of S.
of set S. That's right.
No.
Yeah,
Is
it's
it not subset to the set of S?
to set S. Yeah, that's fine.